to lab 2, atmospheric pressure and temperature as a function of elevation. As you all know by now that temperature and atmospheric pressure vary with elevation due to the same principle driving the ideal gas law. So today we're going to be sampling 7 sites around southwest Portland, and those sites change with elevation, and we'll be examining how pressure and temperature is affected by elevation change.
Okay, we are going to look at the instruments that we're going to use for Lab 2. The first thing we're going to use is this little handheld GPS. I'm going to turn it on with the on button over here. And here he goes. You guys have already gotten coordinates using Google Earth last week. Handheld GPSs aren't super reliable, so you're going to be using those GPS or those coordinates, but we're also going to double check them on this handheld GPS. But if you just scroll over to the waypoint button, and we have our coordinates. So he's pretty easy to use, and we'll be recording those coordinates at each location. We are also going to be recording barometric pressure, and we're going to use this little tiny barometer for that. This guy is already on, but you can just scroll through the different modes to get to the correct function. And here we are at the barometer, and it's giving us our reading in pascals. We're also going to use this for wind speed. You can see this little tiny looking fan up at the top that spins around whenever the wind is blowing through it. And we're going to be able to get a wind speed in miles per hour. What else are we going to use? We're going to use a compass, just a plain old standard compass, to figure out where our cardinal directions are. And when we're outside, we're going to use this little piece of paper, and we're just going to hold it up and see whatever direction the paper is blowing towards, and we're going to get approximate wind direction as well as wind speed. And then finally, we have a sling psychrometer, which is pretty exciting. We're going to get 2 temperature readings from this guy. One is a wet bulb. This little sock, it's not actually a sock, looks like a sock, is at the end of a thermometer, and it's wet. And you can see the thermometer underneath. But then we also have a dry thermometer that doesn't have that little sock over it. And using these 2 temperatures, you're going to be able to calculate dew point and relative humidity, as well as just getting temperature for each of these sites. So I've already wetted my bulb, and once the bulb is wetted, the way this guy works is you swing it around. It's a psychrometer, and you do this for 1.5 minutes. And I'm not going to do it for a whole 1.5 minutes right now, but you'll see us in the fields. Once you've been doing this for 1.5 minutes, there are 2 thermometers. Remember, we have the dry bulb, and we'll be able to read the dry bulb temperature. And we're going to have the wet bulb thermometer with the wet bulb temperature. And we will write those 2 temperatures down. For our purposes, right now, we're going to say that the wet bulb temperature is 60 degrees and the dry bulb temperature is 70 degrees. And you can put this thing back together to be able to figure out relative humidity. And the way this works is we're going to have to line up our wet bulb and our dry bulb temperatures. So our wet bulb temperature was 60, and our dry bulb temperature was 70. So I'm going to scoot that right over. Ooh, that was too far. So our wet bulb 60 is lining up with our dry bulb temperature of 70. And then we use this funny looking arrow, this Y, on this bottom scale to get our relative humidity. So for in this room, our relative humidity is around like 55%. All right, those are the different instruments that we're going to be using today, and we are ready to go out in the fields. What? We are at Southwest 11th and Market Street's over there. The weather is really nice right now. We're in the shade, but it's a pretty open, clear sky. The sun is shining. We're gonna go ahead and start out with our GPS coordinates, which we have right here. 45.51270 degrees north and negative 122. Oh, battery's low. Sorry, negative 122.68616 degrees west. Next, which is 1014.9 pascals. I'm also going to do the wind speed while we've got this guy out here, which it doesn't really feel like there's any wind. I'm going to hold it up in the air. I don't see that it's changing. All right. For location 1, we're going to record a wind speed of 0 because we don't have any wind. Psychrometer. This is the exciting part. So I'm going to pull it out. Remember, we have our wet bulb and our dry bulb. I'm going to have to swing this around for a whole minute and a half. So I'm going to time myself. Here we go. Okay. So I've been swinging this around for a whole minute and a half. I'm going to read our dry bulb first, which has a temperature of 59 degrees Celsius, or I'm sorry, degrees Fahrenheit. 59 degrees Fahrenheit for our wet bulb. And for our dry bulb, we have a temperature of 67 degrees Fahrenheit. Okay, so I'm going to put this back together so we can take a look at our relative humidity. There we go. It's 59. 67. Okay, so I've got our wet bulb and our dry bulb temperatures lined up. And I'm looking at our relative humidity, which is 61%. Now we have to do wind direction. Wind direction now. So we've got our compass, so we know what direction, our cardinal directions. And I'm not expecting this to blow around all that much because we decided our wind speed is 0. Okay, no wind, so no wind speed for location 1, or I'm sorry, wind direction for location 1. And those are all of our measurements for location 1, and we'll see you at location 2 in just